Hello there! Welcome back! If you're interested in learning how to solve rational equations, then you came to the right place. I am here to help you in developing your mathematical skills. In this video presentation, we are going to tackle Lesson 3, Part 1 about solving rational equations. Are you all set? Have your pen and paper ready as we begin with our lesson. For this lesson, you are expected to determine the least common denominator of rational equations and solve rational equations. Let's jump into the main highlight of this lesson. That is solving rational equations. Let's start with an example problem. Look at this. Solve for x if you're given 2 over x plus 1 is equal to 4 over x minus 3. How do we solve this rational equation? Let's look at these steps that I'll be showing as your guide. We'll start with the first one. Eliminate the fractions. Yes, you've heard it right. We are going to eliminate the fractions. In doing so, we can easily manipulate our given equation. So for that, we are going to check the given equation. On the left side, we have a single fraction. On the right side of our equation, we also have a single fraction. That's our clue on how we can proceed with our next step. Since we have a single fraction for both sides of our equation, we can use a technique in mathematics, that is, cross multiplication. We are going to cross multiply. So here, we can do this one. We have 2 multiplied to x minus 3, that's here, is equal to 4 multiplied to x plus 1. I have written here the monomial first, then followed by the binomial for both the left and the right side of the equation. Right after that, we are going to distribute the monomials like this. And now let's distribute. We have 2 times x will give us a 2x. 2 times negative 3 will give us a negative 6. Copy equal sign. Then 4 multiplied to x will result to 4x. And 4 multiplied to positive 1 will give you positive 4. So this is now after the distribution of the monomials. Next one. We are going to apply properties of equality to solve for x. We need to keep in mind that here, we need to have all the variables or all the terms with the variables on the left side of our equation. And on the right side, we are going to have the remaining terms or the constants. So here, we have 2x on the left side. That's a check. We have 4x on the right side. So we need to transfer that to the left side. We still have negative 6 here on the left side. We need to transfer that on the right side. But we cannot easily transfer variables in an equation. We need to follow properties of equality. So for this, let's start with 4x. Let's eliminate that from the right side and transfer it to the left side. So let's use subtraction property of equality. Let's subtract 4x to both sides of our equation. So it would look like this. By doing that, we can cancel 4x from the right side, so we will have this. We copied 2x minus 4x minus 6 is equal to, copy the remaining term, that's 4. Here, what we want to achieve is just to transfer all the variables on the left side and all the constants on the right side of our equation. So we still have negative 6 here. We need to transfer that to the right side. So let's use addition property of equality to eliminate negative 6 and add 6 to both sides of our equation. So we have this one. So we have negative 6 plus 6 will be canceled out because that will give us a 0. And we have here 4 plus 6. Now our main objective is just to transfer, right? We did not operate yet, like this one. We did not do something about that one yet. So I just copied here 2x minus 4x is equal to 4 plus 6. Let's make use of that and proceed to the next step. So let's combine like terms. We have 2x minus 4x. The answer for that will give you negative 2x. And 4 plus 6 on the right side will also give you a positive 10. So you have negative 2x is equal to 10. Next, so to get the answer, we still have here negative 2 as the coefficient of our unknown. And our main goal is to find the value of x. So we need to eliminate negative 2 right here so that we are left with the value of x. So to do that, we are going to use division property of equality. Let's divide both sides by negative 2, like this. We can cancel negative 2, and the result will be 10 divided by negative 2 will give us a negative 5. And that will be the value of x. X is equal to negative 5. To confirm our answer, we need to proceed to the last step, and that is the checking. Using that value, x is equal to negative 5, we will go back to the original equation, which is this one, and we are going to substitute the value of x by negative 5, like this. So these are the values of our x. We have already substituted that in this equation. After that, we will perform the indicated operation. So it will have this one. Copy 2, negative 5 plus 1 will give us negative 4. And we also have on the right side, we'll copy 4 divided by negative 5 minus 3. The result for that is a negative 8. So it would look like this. Now, since we can reduce this fraction at the same time the right side as well, it would now look like this one. Since the left side and the right side are the same, that confirms our answer, which is correct. Our value of x, which is negative 5, is a correct answer. We are done with the first example. Let's have another one. Try this. Solve for x if you're given 5 over x minus 1 over 2x is equal to 9 over x squared. You may pause this video and take your time. Alright, to solve for this, let's look at the solution. We will start by eliminating the fractions, right? We need to check first our given. Unlike our first example, wherein we have a single fraction in the left and right side of the equation, this time it's different. We have one fraction minus another fraction is equal to a single fraction. Our next step will be we will find the least common denominator. So we will find the LCD. So how to do that? First is we will copy the denominators like this. We have x, 2x, and x squared. So we have it here. And then we are going to write it in factor form. Since we already have here a single variable, we will write the factor as x. Here we have 2x. So we have the numerical coefficient 2, and we also have the variable x. So let's write it separately. We have 2 and x. I am aligning similar variables like this. Followed by x squared. That's written as x times x. Now to get the LCD here, you need to remember, for factors that are alone like 2, we will copy that like this. That's already part of our LCD. For factors that are common to 2 or more denominators, like this one, it's common to the 3 denominators, which is x, you will only copy that one once. So again, for factors that are common to 2 or to all the denominators in the given equation, you will copy that one once, like this. For the remaining factor, which is x, it's alone, then you can write it here. So our LCD is 2 times x, which will give us a 2x squared. Getting the LCD, that will be our guide. We will use that in multiplying to all the terms of our equation. So what I mean is like this. Again, we will use the LCD and we will multiply that one to the given equation, like this. What I did is I copied the given equation, which is 5x minus 1 over 2x is equal to 9 over x squared like this. And on the left side, I multiply that to 2x squared, which is our LCD. Same to the right side. We have here copying 9 over x squared, multiplying it to 2x squared. Do you understand? On the left side of our equation, this one, we have two terms. So we need to distribute 2x squared to the first and also to the second term, like this. It will give us something like this. I'm showing to you that I multiplied the LCD, which is 2x squared, to the first term. That's 5 over x. I copied minus. Again, I copied the LCD because I multiplied that to the second term, which is 1 over 2x. I copied the equal sign. Here, we have 9 over x squared and multiplied to the LCD. So here, we are going to look for common factors that we can cancel out. So let's focus on the first one, which is this one. In the LCD and in the denominator, do we have a common factor that we can cancel out? Yes, that would be the variable x. It's common. We have here x at the same time x in the denominator. But x squared here means x times x. Once you cancel that one out with x here in the denominator, we still have our remaining x here in the LCD. So, it would look like this. Allow me to annotate for clarification purposes. We still have, again, that's 2, so we still have remaining 1. So, do not forget that. For the second one, we still have a common factor, right? We are going to cancel 2 first, and then we also have x. So let's cancel that one out. Again, we still have a remaining x here since we have x squared there. So only one x has been canceled. I'll erase that and let's continue. How about on the right side? We can cancel a common factor, which is x squared. Very good. So we are going to cancel that one out like this. So to simplify that one, showing you the remaining terms, it will look like this. There. So we have here again, we have a remaining x. So we have 2x multiplied to 5 minus x, the remaining x here, times 1 is equal to 9 times 2. See, from the given rational equation, after multiplying the LCD to both sides of our equation, it looks like this. That's the beauty of our LCD. Let's make use of that. We're going to multiply. We have 2x times 5 will give us a 10x. Minus x times 1 will give us a negative x. And on the right side, we have 9 times 2, which will give us a positive 18. Here, the next step is we are going to combine like terms. We have 10x minus x, and that will result to a positive 9x. And we'll copy 18. We still have a coefficient beside our x, so you're going to eliminate 9 so that we are left with our unknown, which is what we are looking for. That's the value of x. So that's x here on the left side. So to do that, we are going to use division property of equality. So we are going to divide both sides by 9 like this to cancel out 9. So the result for 18 over 9 is a positive 2. So we already found the value of x, that's positive 2. Now, how to make sure that our answer is correct? What's our final step? We are going to use that value for the checking. Making use of the original rational equation, we are going to substitute x with positive 2. So it would look like this. There you go. So these are the x being replaced with positive 2. So this time, we'll perform the indicated operation. So we'll copy this one, 5 over 2, like this. Copy minus. Then we have 1 over 2 times 2 will give us a 4. Equal sign, 9 over 2 squared is equal to positive 4. So you're going to look for the LCD here. That will be 4, making use of your knowledge in the previous lesson. So we can have this one as this. So here we have the same denominator. We can now subtract the numerators. 10 minus 1 will give you a positive 9 over 4 Exactly the same with 9 over 4 on the right side of your equation. Thus, again, since our left and right side are the same, it confirms that our answer of x is equal to 2 is the correct answer. Well, this time, let's go an extra mile as we answer this third and last example. Solve for x. If the given is 2 over x plus 1 plus 3 over x is equal to 5 over x minus 2. I know you can do it. Give it a try. To answer this, let's look at the steps. Step 1. Exactly, same as our first and second example. We are going to find a way to eliminate the fractions. Checking our given, we have here two rational expressions on the left side, and equal to the right side, we have a single rational expression. So our next step will be, similar to example number 2, we are going to find the LCD. So let's copy each of the denominators. We have x plus 1, x, and x minus 2. Now this time, I'm writing it in this manner because we don't have any common factor. So that means, for this case, we are going to copy everything. We are going to start with the monomial followed by the binomials, like this. You are going to have the LCD as x multiplied to the quantity of x plus 1 times x minus 2. We already found our LCD, so let's make use of that. There. Our next step is, we are going to multiply all the terms of our given equation to our LCD, like this. So what I did here is I copied the LCD here on the left side and on the right side. But since on the left side, we have two terms, that means we are going to distribute this LCD to the first and to the second term, like this. Are you following? So let's make use of that line. Allow me to copy that line. And this time, we are going to look for common factors in the LCD and in the denominators of our given. So right here. So let's have this one first. So what are the common factors? We have x plus 1 and we also have x plus 1 here. So we are going to cancel that one out like this. How about on this line? Do we have a common factor? Yes, that would be x. Let's cancel that one out. On the right side of our equation, do we have a common factor? Right, that will be x minus 2. After canceling out common factors, it would look like this. So we are left with x and x minus 2, which is this one, and multiplied it to 2. Plus, we have x plus 1 and x minus 2 multiplied to 3. And on the right side, we have 5, copied x and x plus 1. There you go. Now, our next step will be, what do you think? That's right. We are going to perform the indicated operation. So let's focus on the first line right here. So we have a monomial x, and we have a binomial x minus 2, and we still have 2. So what we can do here is, we can combine the monomial first, then we can multiply that to x minus 2. Or, another way is we can simplify this one first and multiply that to 2. But for this example, I'm going to combine 2 and x first before multiplying it to x minus 2, like this. And on the second part, which is this one, what I did is I just copied 3 and I multiplied the two binomials. So I have x plus 1 times x minus 2. So here, allow me to annotate. We have x multiplied to x, that's why you have x squared. We have x times negative 2 will give you a negative 2x. And then we have 1 times x will give us a positive x. 1 times negative 2 will give us a negative 2. Do not forget to enclose that in parentheses because you are still going to multiply that to the remaining number here, which is 3. Now, on the right side, we have 5 and we also have x. Let's multiply that one. That's why we have 5x here, and I copied x plus 1. Do you understand? Okay, allow me to erase. So here, what we can do is, let's simplify this one first, and we'll just copy the rest like this. So what I did right here is, I just combined like terms. So we have x squared minus x minus 2, and copied the rest. Okay, so after that, we are going to multiply or distribute the monomials. We are going to have 2x here multiplied to the terms of our binomial, and we also have 3 multiplied to all the terms of our polynomial. And also on the right side, doing the same thing, multiplying 5x to all the terms of our binomial. So it would look like this. I will guide you, so do not worry. So we have here 2x times x will give you a 2x squared. 2x times negative 2 will give you a negative 4x. Plus, we have 3 right here. Multiply that to x squared, you have 3x squared. We also have a 3. You multiply that to x or negative x, that will give you a negative 3x. And we have 3 multiplied to negative 2, which will give you a negative 6. On the right side, we have 5x, right? Let's multiply that to x. We'll have 5x squared. 5x multiplied to 1 will give you a 5x. That's how we come up with that next line. Allow me to erase. Let's proceed. So this time, we are going to combine like terms, like this. So we have 2x squared, and another one is 3x squared, like this. And the other similar terms are negative 4x and negative 3x, and I just copied negative 6. And on the right side, we just copy it as is. So 5x squared plus 5x. Now let's make use of that. So we are going to combine like terms this time, which will give us 5x squared minus 7x minus 6 is equal to 5x squared plus 5x. So what I did here, how did I come up with 5x squared? I added 2x squared and 3x squared. For negative 7x, that will be the result of negative 3x minus 4x. I copied negative 6 and also the remaining terms on the right side of the equation. So our goal now is to make sure that all the variables are placed on the left side of the equation and the constants or the remaining terms on the right side. So let's start with the highest degree, that's 5x squared. We can use subtraction property of equalities. So we have negative or minus 5x squared, like this, and we can cancel it out. 5x squared minus 5x squared will give you 0, meaning it has been canceled out for both sides of our equation. So we are left with negative 7x minus 6 is equal to 5x. Okay, let's make use of that. After that, we are going to subtract 5x. Again, making sure that on the left side, we have those terms with the variables. So it will look like this. So negative 7x minus 5x minus 6 is equal to 0. Last one, we are going to transfer negative 6 to the right side of our equation, giving us like this. Add 6 to both sides, cancel 6, so we are left with this. So we have negative 7x minus 5x is equal to 6. So let's combine this one. We'll have negative 12x is equal to 6. Using that, we have this. And this time, we're going to eliminate the numerical coefficient of our unknown, which is the variable x. So let's divide both sides by negative 12. Cancel negative 12. We are left with x is equal to 6 over negative 12 is negative 6 over 12. Reducing that one, we'll have negative 1/2 or negative 0.5. And that's our answer. To confirm if our answer is correct, we'll use that value for the checking. We have here the original equation. We'll now substitute the value of x by negative 0.5. So it will look like this. We already have replaced x by negative 0.5. Let's do or perform the indicated operation. So we'll have this step. I hope you're able to follow. Dividing that, you can have this. So we have 2 over 0.5 will give you a 4. 3 over negative 0.5 will give you a negative 6. 5 over negative 2.5 will give you a negative 2. So we have 4 plus negative 6 will give you negative 2 is equal to, copy the right side, negative 2. Since the left and the right side are equal, that confirms that our answer is correct. X is indeed equal to negative 0.5. We have completed the 3 examples. This time, it's your turn to check your understanding. I prepared an activity for you. It's activity time. Solve each and find X. I will include the answer key in the description of this video. If you want to confirm your answer, you may check it out. And that concludes our lesson about solving rational equations. I hope you've learned something useful today. Congratulations on always doing your best. Keep it up and see you in the next lesson.